Guys, today we are gonna discuss or I'm gonna show you the properties about probability, and the set function. Probability like a set function, the probability set function. This is the topic, the probability set function. Okay, we have an special collation. This one is a sample space. A sample space. It's a collation. And we need to define the events about that sample space. This collection of events. Which denote by that letter is like a beta. Beta is this is a collection of events. We have that collection has specified properties, but in this case I won't tell you because we need to be more mathematical technically in the result, So for this moment I need that you try to think. They're probably like intuition of relative frequency. If you think they're probably like intuition relative frequency, that property is the node. For example, we suppose that you have a whatever event in that collation, in that collation. Yes, this one and this one, that collation, and you want to define that function, this one over a, and this one is number of I don't know how to say that. This one is the number of times a occurred, so you do different experiments. Yes, that different experiments, aleatory experiments, and n times. Yes, n times, and in that maybe a little sample space, so occurs a, so you can define that function. Yes, and this function have specific properties, like is greater than 0, and if a c, I'm sorry, this one is the correct notation. Yes, yeah, is 1, because if you look at if occurred the simple space, always fa is equals 1, so yes. Okay, so we want to define that set function in this way, so let C a simple space and sample space, and beta is a collection of events. Yes, and they have a specific properties, but in the sigma algebra, but in that moment I don't tell you anything about it. So probably set function satisfies the following three conditions. that condition. The one condition is this one: probability set is greater or equal 0 for all sets in below that collection, yes. Probability of this one is equals 1, probability of the sample space. And the theory is, if you have a disjoint, yes, you have a disjoint events, 1, 2, whatever events, that events belong in that collection, yes. The probability of union or whatever pairwise disjoint sets, it equals on this one. This is the third properties, the Komodoro actions for in order to define the probability, like cassette functions, yes. No more. Thanks. Bye bye.